Hello and welcome to Unit 4, Lesson 5, Conditionals Explore. This brings up a new idea, conditionals in computer science, and it builds off of the work that you did in Unit 4, Lesson 1, where you started to use manipulatives to talk about variables. Today we're going to do the activity together. So to get started, you are going to need a small snack of red, yellow, and blue stickies. Like these. If you don't have these colors, that's totally fine. You could pick 3 different colors, but we're going to use the 2 colors that you used last time to describe strings and numbers. And then we're going to need an additional color because we're actually going to add an additional type to our knowledge base. We are going to also need some plastic baggies like you had before, a pen and pencil, and a dry erase marker. One of these. If you don't have a dry erase marker, but you want to write on the bags like we did last time, another option might be to take a piece of paper and put it behind the bag, then write directly on that paper, and so you can see through the bag your variable label for that particular bag. So if you have these items and you would like to physically move them around, go ahead, pause this video right now, find those within your house, and come back together. If you don't have these items but you still want to have that visual manipulative, please use the manipulatives created by code.org and shared with you on Code Studio. So either way, take a moment and pause this video, get your supplies, and when you're ready, come on back. Welcome back. We have already thought about information, and information can be stored as numbers. Those are things with the digits 0 through 9. These don't have quotation marks, and we're going to use yellow sticky notes to represent numbers. We've also talked about strings. These are characters. They are inside double quotes, and they are red sticky notes. So anything that can be a word, a string, might also include numbers, but things inside of quotation marks will be a string. So today we're going to add another item. This is called a Boolean. A Boolean value is either a true or false. And for that, we are going to use the blue sticky notes. So go ahead and right now, write 1 true sticky note and 1 false sticky note. Write true on one and false on the other. Pause me if you need to, and write down true and false. You will only need one of each of these. Okay, keep going. So a Boolean value helps us determine whether something is true or false. Here's an example. We have an expression, which is 3 is less than 8, and we want to determine what this evaluates to. So go ahead and hold up to the computer or to yourself the sticky note that evaluates correctly here. Is this a true statement or a false statement? 3 is less than 8. This statement is true because 3 is in fact less than 8. And so we put true on our sticky note. This tells us this is a true this evaluates to a true statement. And I want to pause here and take a moment and look at this comparison operator. It's a clue that we need to stop and evaluate for a Boolean value. So anytime I look at my code and I see an expression with one of these comparison operators, in the bottom of the screen you'll see 6 different versions. That tells me, pause, go ahead and evaluate this for a Boolean value, and then continue on working with our code. These are our different comparison operators, and the less than symbol is one of these. We also have others which you may or may not be familiar with. We have less than, greater than, those look pretty familiar. Less than or equal to is something that we usually see on a computer screen, or in our math class perhaps, as something that looks more like this. But on our computer screen and when we are typing with our keyboard, we don't have that button on our keyboard. So we use the less than followed by the equal sign to mean less than or equal to. And similarly, this might be greater than or equal to in math class, but in computer science, we use the greater than followed by the equal to sign in our programs. We also have an equal to symbol right here. And that's a little bit different than what you've thought about, again, in math class, where we just have one equals. But here we have two. When we look at something with two equal signs in a row, that tells us we want to evaluate whether an expression is true. For example, is 3 equal to 8? Not true. Rather than having a value with and just a single equal sign, which would tell us I want something, some variable, to get the value 8. For example, x gets the value 8. We also have one more. This is not equal to. So over here we have the exclamation point followed by an equals to is not equal to. For example, 3 is not equal to 8 would evaluate to true. So when we're evaluating, we must make sure that everything on one side of an operator is evaluated first or reduced before we can compare. So here's an example of a slightly more complicated expression. We have 3 plus 6 is less than 8. The first thing that we do is process what happens on that left side. And we say, is 3 plus 6 less than 8? Okay, let me figure out what that evaluates to. 3 plus 6 is 9. And then we check, is 9 less than 8? True or false? What do you think? Of course, 9 less than 8, not true. That is a false statement. So this whole thing, the 3 plus 6 is less than 8, would evaluate to false. So here's what I want you to do. I want you to work through this process for a minute. So you're going to pause the video. You're going to evaluate the expressions on each side of the comparison operator. Perhaps use your manipulative. So go ahead and make some post-it notes, process them out, and then determine whether the whole statement, for example, 6 minus 3 is less than 4 plus 1. Does that evaluate to a true or a false statement? So determine what each side of the expression evaluates to, and then evaluate the expression for a Boolean value. Go ahead and pause this video, take a moment to walk through these, and then we will double check your work together. Okay, welcome back. Let's take a look at what we've got here. We have 3 is less than 5. Is that a true statement? Why, yes, it is. 12 divided by 6 is greater than 3 minus 0, also known as 2 is greater than 3. No, it's not. That is a false statement. When we look at this next one, we get 12 is less than or equal to 10. So we're evaluating everything on the left-hand side, and then we're just comparing it to something on the right-hand side. 12 is less than 10, less than or equal to 10. That is not a true statement. 9 plus 5 is equal to 4 plus 10. 9 plus 5 is 14. 4 plus 10 is 14. 14 is, in fact, equal to 14. So now we have looked through a few expressions. Great. We have figured out how to evaluate both sides and then come up with a Boolean value. So now that we've figured out a little bit about expressions, we want to use that information to mean something to our computer. So let's take a moment, think back about variables. In fact, any of the values in an expression can be a variable. So here, for example, is an expression that lives plus 4 is less than score minus 1. And I want you to pause this video and evaluate the expression for a single Boolean value. So what you probably just did was something that looks like this. You took the value of lives and the value of score and input them for those variables. So we have 5 plus 4 is less than score minus 10, or 10 minus 1, excuse me. And we get 9 is less than 9. Is that a true statement? In fact, no, it is false. 9 is not less than 9. So now we have taken a variable and added into our equation so that we can evaluate something that might have a different value depending on what the variable represents. Slight note, any expression that can be evaluated for true or false is known as a Boolean expression. So what you have been working with so far are Boolean expressions. So why are these so cool in computer science? Why would I bother caring about Booleans? They help computers look like they're making decisions. So they can make choices based on whether something is true or false. Here, for example, is a statement. Can I go to the movies? I'm allowed to if it's before 8 o'clock. So pause for a moment with this video. What information do I need to know? Go ahead and create a baggie, a variable, and store that information. Give it a name. So can I go to the movies? I'm allowed to if it's before 8 o'clock. That means I need a variable called time because I want to know what time it is. Now, you may have named your variable hour or something different. That's totally fine, but you want to represent what time is it now. So this, what you see in front of you, is called a flowchart. A flowchart kind of helps us figure out a decision. And so I start with the information that's at the very top. So I start with time with some value I'm going to put in there. I process it by looking at how this evaluates this Boolean expression. And then depending on what the answer is, I will get one result or another. So can I go to the movies? I'm allowed to if it's before 8 o'clock. Let's say it's 9 o'clock. Can I go to the movies? Okay, so let's process this together. I'm going to put 9 in for my time. Assign 9 to the variable time. Great, let's keep going. Now I'm going to input 9 into time in my Boolean expression. I see that I have a comparison operator. Okay, let's do some comparing. 9 is less than 8. Is this a true or a false statement? In fact, it is false, so I'm going to keep following this flowchart, and then I am going to follow down this false path. I cannot go to the movies. Have to try again later. Here's another statement. Have I won a game? So thinking about programming, I might be programming a game. Has my user won? I have if my score times my lives is greater than 10. Okay, let's pause. Create baggy variables, perhaps more than one, to store the information. Give them names. What do you think? Pause the video. Take a minute to think about what the Boolean expression will look like. What will be compared? So go ahead and fill out your bags or multiple baggies, and then keep going. Okay, so I'm going to have 2 bags. I'm going to have 1 for my score and 1 for my lives. So I'm going to have score, and I probably am going to create another bag with a sticky note called lives. So here's a flowchart to represent have I won the game. I have if my score times my lives is greater than 10. I have 2 baggies, score and lives, to represent my 2 variables. And what I would like for you to do is pause the video, follow the flowchart with these imports. There are 3 different tests. And chances are your flowchart is going to give you a different result depending on your input. So go ahead and pause and we'll look at this together afterwards. Okay, so I'm going to do an example where I put in the values for score and lives. So for my score, I've got 3. For my lives, I also have 3. When I take those values and put them in to my expression, I have score gets the value of 3, lives is also 3. 3 times 3 evaluates to 9. Is 9 greater than 10? 9 greater than 10 is a false statement. Unfortunately for me, I have just evaluated this expression and I need to follow down this path. I haven't won the game yet. Keep trying. So here's a challenge. Is my dog older than me if his age is converted to human years? Just so you know, 7 dog years equals 1 human year. So every year that I grow older by 1 year, in dog years, my dog goes older by 7 years. So I want you to, again, think about what information you need to know. Create a baggie or baggies to store that information. Give them names. And then what do you think? Pause the video. Take a minute to think about what the Boolean value and expression will look like. What will be compared? Here's an example of that flowchart. So, dog age, my age are the 2 inputs that I have added here. Dog age times 7 is greater than my age. If that is true, my dog is older than me. If that is false, I am older than my dog. So for example here, if my dog age were 2, 2, and my age is 15, dog age times 7, 2 times 7 is going to be 14. Is 14 greater than 15? No, it is not. So at this point, whew, I am older than my dog. Here's another example. What if my decision requires multiple steps? Can I adopt a cat? I can if I have $40 and I'm over 14 years old. What would that look like in a flowchart? What do you think? Think about what information you need to know. Go ahead and create variable bags to store that information. Give them names. And then decide what your flowchart would look like. How would you set it up? What would be your Boolean expressions? And it sounds like you're going to need more than one. What is going to be compared? Pause this video if you'd like. We're going to move on to a flowchart. So here are my 2 inputs. I have money and I have age. I am checking first, is my age over 14 years old? Okay, if that is a true statement, I also need to check whether my money is equal to 40. If age is less than 14, I don't need to check how much money I have because I already know that I'm not going to be able to adopt a cat. One more thing to notice here is that when we think about computing and what we say in particular, it's really important. So here I say, I can have, if I have $40, not if I have more than $40, if I have 40 or more dollars, I say, if I can do this if I have $40. So in this particular case, particularly when we're transitioning to a Boolean expression, we're checking if money is exactly the value 40, not if it's greater than or equal to 40, which you may have written down. So let's try it out. Let's say I am 17 years old today. I have $39. So let's walk through this process. Both of these go in my post-it notes for money and age in the variables. I can take those values and input them in my first Boolean expression. My age is 17, which is greater than 14. That is a true statement, so I'm going to follow this path. Once I'm here, I'm checking, is my money value equal to 40? 39 equal to 40? Well, darn, that is false. So now that I am here in my flowchart, I'm going to follow the false path. And it turns out today I do not get to adopt a cat. Bummer. So Boolean values are a type of information, and they can also be evaluated in a Boolean expression using logical operators. Logical operators, here's a new vocabulary term, are and, or, and not. On our computer, when I say and I say something is true and false, it evaluates to false. And just a note here that and as the word is represented in our computers as 2 ampersand signs, or is 2 vertical lines, and not is this exclamation point, which makes sense from what we did earlier when we noticed that we had exclamation point equals was not equal to. So we're going to take a look at something called a truth table. In the next few slides, I'm going to change the color of the stickies just a bit. So these are going to be your blue stickies. True is going to be a dark blue, and false is going to be a light blue. I'm going to show you something called a truth table, which you can think of as kind of a graphic organizer for how to think about these and, or, and not statements. So, used in evaluating Boolean expressions, this is an and truth table. I have true and true, and I want to think about if I have something that is true and something else that is true, what does the whole statement evaluate to? So, for example, if you look down in the little picture, you'll see I am holding up my right hand and I am holding up my left hand. That whole statement is true, and so the whole thing evaluates to true. If I have something that is true and false, what does the whole statement evaluate true? I am holding up my right hand and I am holding up my left hand. If you think about it, that whole statement is actually false looking at my picture, and so the statement evaluates to false. If I have a false and a true, the same thing happens. And if I have 2 false statements, I am holding up my right hand and I am holding up my left hand, both of those are false, which means the whole statement evaluates to false. As a general understanding, if you have the ampersand or the and expression in your expression, both things must be true for the whole expression to evaluate to true. Here's another one. I want you to predict the results for each line in the or table. We have a true statement, an or, another true statement. I am holding up my right hand, or I am holding up my left hand. A true or a false. I am holding up my right hand, or I am not holding up my left hand. Evaluate each of these expressions, and then we'll walk through them together. Okay, so if I have a true or another true, the whole expression evaluates to true. If I am a true statement or a false statement, the whole expression evaluates to true because at least part of it was true. The same is correct for a false or true statement. And if something is false or another thing is false, no part of that is true, then that evaluates to false. Another way to think about this is that if you have an or statement, either may be true for the Boolean expression to evaluate as true. So as long as there is one true portion of the statement, the or statement evaluates to true. The not table is pretty easy. The results are the opposite for each Boolean value. So if we say not true, we mean false. If we say not false, we mean true. What I want you to do is use logical operators to combine several Boolean expressions into one expression. Go back to this, can I adopt a cat? I can if I have $40 and I'm over 14 years old. Can you write a single Boolean expression that represent this whole statement? Here's an example of what that would look like. So my money is equal to 40 and my age is greater than 14. Let's try it out. I'm 15 years old and I have $40. Let's see. I put those values into my variables. I evaluate 40 is equal to 40 and 15 is greater than 14. Okay, let's process those one side at a time. True. And 15 greater than 14, true. If I have an and statement, true and true. Remembering our truth table, that whole thing evaluates to true, which means in my flowchart, I follow down here and I can adopt a cat today. Great! So, to finish up our flowchart activity, this is your turn. What I would like for you to do on a scrap sheet of paper is think back to the warm-up, which you did this morning or earlier today, where you discussed making the decision on what to wear to an event. If you did not do the warm-up, go ahead and write down a question about something that you would need a decision to be made. I then want you to write down the variables in the boxes at the top. So you're going to make something that looks like the flowchart on this screen. Inside the diamond shape, create the Boolean expression that will be used to make the decision. Draw true and false lines to possible decisions, and what those decisions would be. A challenge might be to use logical operators, an and, an or a not in your Boolean expression, depending on what your statement is or the decision you are trying to make. So go ahead and draw this out. Take a minute, pause this video. Test your flowchart with a friend or a family member. Give them some values, see how they do. Welcome back. I hope you had some flowchart success. You can see how Boolean values will help with decision making. To wrap up today, I want to give you some takeaways as we think about Boolean decisions. So a Boolean value is a data type that is either true or false. We represented those with blue sticky notes today. A comparison operator, greater than, less than, greater than or equal to, less than or equal to, or not equal to, indicates that you should evaluate a Boolean expression. When we do this, each side of the Boolean expression is reduced to a single value. And then single values are compared, and the result is a Boolean value, true or false. We also talked about Boolean operators. We have, logical operators. Boolean expressions include and, or not. Both sides of a logical operator are reduced to a single Boolean value. And then a truth table is used to evaluate the reduced Boolean expression to a single Boolean value. A decision is made with a single Boolean value, and a flowchart can be used to illustrate the steps of making a decision with a Boolean expression. Thank you for joining me today. This has been Unit 4, Lesson 5 activity about comparisons, Boolean values, and conditionals. Take care.